Okay, it says that OBS claims that it can see audio. I'm getting a VU level, so it's quite possible that you can hear me. I don't know. You just can't see me, and that's perfect. This is just the way I like it. We have audio, yes. Okay, well that's kind of a start. It just doesn't like the audio input capture is coming from that. All right, that and that. So why is it not? Yeah, it's now Radio Superhouse. Hey, Dentistries. So why is that not working? I'm just going to try changing video sources and then back to... There we go. OBS needed to be changed away from the video source and then back again. Hang on. Audio level down. There we go. I think we're okay. That was a weird thing from OBS. It needed the camera deselected and then reselected. Awesome. Well, good morning, everybody. Sadly, there is no TTS again this week, but hopefully Mitchell will get it sorted at some point, because it's sad when there's no TTS. Right. Good morning to everybody. So now I've got to scroll back up, starting with good morning to Don S, all the way from New Zealand. Also, good morning to Matt W, Sharky, Outside the Box, aka Crispian, Tabraze, Scott Miller, Lionel Mazels, good morning, John Whips, Stephen George, where are we? Grant Mazels is here as well, Scott Miller, Simon, Russell Rainey, Any Mules, Stephen W said John is hiding. Yeah, I feel like hiding. I'll explain in a second. Imi, good morning, Imogen. Tech Nebulous, I've said hello to, I think. I have now, anyway. Scrolling. Who else? Johnny Bergdahl. Guten Tag. Guten Tag, Johnny. Still scrolling. Who else have I got? Oh yes, Dentistries, David C, Cassio, Andrew Brown. Good to see you all. Okay, now hang on. Before I forget, because it's very easy for me to get sidetracked, as you know. First, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, I have a thing. No, okay. First, where am I? I've got to find the chat again. There it is. First, okay, I'm going to say, I'm going to stick something in chat. And this is an example for you all to follow. I finally updated Testomatic with the modified plastic to improve test module clearance. Sorry, I'm typing and talking at the same time. So, nerd brags. Outside the box says, all the Mazels? No, we don't have all the Mazels here. Shika, yeah. My keyboard is cool. I am so happy with this keyboard. I don't actually need another one the same, but I have this urge to make another keyboard, another Softlight Shock keyboard, just because this one, it's like, I don't know quite how to explain it, but the process of ending up with this keyboard has been so satisfying, and the feeling of using it is so satisfying, that I want to make another one just kind of like a celebration of it, or a way of recreating that sense of satisfaction, even though it wouldn't be the same the second time, because I don't need it. If I had a second one, it would just, I don't know where it would be. It would no, I don't even have anywhere to use it at home, because I don't have like a proper desk or anything at home. I just have my laptop, and I don't even really have anywhere proper to sit. Donna says, it brings you joy. It does. Yes. Scott says, a spare in case of spillage. Well, that is a valid point. Maybe I should have a spare. Yeah, that's true. I should have a spare. Simon said, put one on the P&P machines. No. The P&P machines have compact keyboards on them, mounted on little arms that come out from the front. So I'm hearing sounds that sound like they're coming from inside the factory, but I might be wrong. Yes. Grant asked, don't you wear out keyboards? Oh, I sure do. I have been through so many keyboards. I have written so many hundreds of thousands of words over the decades. I have worn out, that I can think of, 7 keyboards over, probably more than that actually, over the last 20-ish years. So a keyboard every few years, that sounds about right. Yeah, it's something like that. So this one will wear out. But the thing is that because this has pluggable software chock keys in it, any keys that are damaged or have problems, I can just unplug them and plug a new one in, and I have spares. So yeah, that is good. That is the good thing about making a keyboard yourself, is that it's all fixable and modifiable. Okay, we got our first nerd brag from Crispian. He says, got up this morning. That is a good thing to celebrate. I very nearly didn't. So, for context, last Sunday I had a little bit of a tickle in my throat and I coughed a few times during the stream. That turned into a proper chest infection, and all week I have been feeling pretty bad. I haven't had like congestion, so I haven't sounded like I'm sick, but it's been on my chest. I've had a chest infection, so I've had really bad deep coughs, and it's kept me awake at night. So a fair bit of the night last night. The problem is when I lie down, that's when the chest cough really begins. And so I don't get very much sleep. I haven't had much sleep this week, including last night. I got very little last night, so I'm feeling zonked, really zonked. Right, okay, our dentistry said, quite apart from everything else, it's 01:10 a.m. here. Yeah, you're up late. Yeah, I will feel better. I'm actually on the improve, I think. I'm feeling better now than I was a few days ago. Tabray said, you had a bad cough this time last year. Is it seasonal? No, it happens to me. Yeah, there are seasonal elements to it. But one of the complications is because I have Crohn's disease and I am on immunosuppressant medication, it makes me more of a fertile breeding ground for for things that would attack my body. So yes, I really should spend a whole lot more time wearing a mask than I do, because I'm more prone to pick up random things just through general social interactions and stuff than a typical person with a normal functioning immune system. And I'm kind of blasé about it, and I just act as if I'm as indestructible as everybody else. And the result is that I am not as indestructible as everybody else, and I catch things. Yeah, so I'm going to be due for my next round of medication before too long. So, right, where are we up to? Okay, so, Testomatic. Oh, that's right, I read part of Dentistry's comment, and not the rest. So, which was, but could we get an updated tour of the Super Lab Plus factory sometime? If not live, then maybe a vlog. Yes. Yes, that is something I should do, because if you haven't seen anything for a while, on live streams a few times, like last week, did I assemble a board last week? I have a feeling that I assembled, what was it? The Testomatic board. Sometime in the last week, I've done a live board assembly on a live stream, which included showing video from the security camera of the clean room. It doesn't give you a great view though. It's just sort of like looking down from the corner, like a bird's eye view. And yeah, so things have changed. For one, if you haven't seen it for a few months, the entire production line has been rotated 180 degrees. So it now starts at the far end of the room and it comes towards me instead of the other way. There is now also an automated solder, well, semi-automated I should say, solder paste printer at the far end where the reflow oven used to be, and the reflow oven is down this end. So it's got more machinery in there than there was before. And any mules pointed out, be good to see a run through once the conveyors are working. Yes, that's true. Oh, we got a nerd brag from Don. Set up an ARPi 5 with tail scale and got laptop connected to remote Allen Bradley PLC over secure VPN. Yeah, nice. That's good work. Hopefully the PLC is not controlling anything that will do too much damage if something bad happens remotely. Scott says, I remember a time when this channel had more than just live streams. Yeah, it does. I actually opened Final Cut Pro last weekend, last Sunday actually, after the live stream. I opened Final Cut Pro, and because the actual motivation was to pull in scuba diving footage so that I could mash a whole bunch of them together and just make like an ambient background dive clip, you know, like half an hour or something of just wandering around underwater looking at fish and flat sharks and that sort of thing. And in so doing, I moved all of my libraries. What happened? Yeah, I've got terabytes and terabytes of video on disk, and so Final Cut, what I had to do was migrate my libraries, my Final Cut libraries, onto the NAS, and I then made a local copy of the library that I use for my current working project so that it's on a local SSD, and also updated the format of the libraries to the latest Final Cut format, and that took like 12 hours, I think. Or something in that region. I started the copy and then it was done when I came back the next day. So yeah, it was one of those things where I thought, I'll just open Final Cut, which I hadn't opened for maybe a year, and like pull in some video and start editing. But just to get to the starting point was like 12 hours worth of files moving around and things. So yeah, I do actually now have Final Cut running updated on my computer with a local copy of the working library on my local SSD and all of the other stuff, including all of the video source files, on the NAS. So I am now, as of last weekend, back in a position where I can pull in video footage and start editing it again. Part of it is just my own aversion to, this is going to sound so stupid considering that I am sitting here right now talking to you on a live stream, but a large part of it is actually my aversion to being on camera. I have never got used to it. I'm actually way more used to these live streams than I am doing like staged, recorded and edited video. That just, it feels so wrong and alien and I can't stand it. So yeah, but I am determined to try to do it. So yes, I'm going to try. All right, now there were a couple more humble brags. Okay, Imi said artist brag. No, not humble brags. A humble brag is a negative thing. I'm talking about a nerd brag here. Okay, artist brag from Imi. Just finished my art piece and now I'm waiting to take it in for the exhibition tomorrow. Excellent. So you take it in tomorrow and then I guess the exhibition starts this week? Something like that? That's really cool, Imi. Congratulations. Eddie Mule said, nerd brag, I installed... no, I don't know if this is a typo, but this is actual... This could be intentional and it could be funny. So it's a need brag, not a nerd brag. So a need brag is when you do something because you need it. Need brag is I installed Home Assistant in a Docker container on my RPi 4, got my solar battery integrated with it via Modbus. Now I get pretty solar and battery generation graphs. Nice. Very nice. That's cool. Yeah, I need to do some more with Home Assistant. Right now, Home Assistant is on that. The new wireless power Raspberry Pi. So I've just put it into a little 3D printed case which goes into a rack. Where is it? Somewhere not within arm's reach. There's a 1U rack, like a 3D printed rack mechanism that can handle up to 6 of these. It's got slots in it, so you slot Raspberry Pis or whatever into it, and each module can hold 1 Raspberry Pi, or you can make modules for holding different things if you wanted to, or you could make it like a double width module. And this particular one, it's got a little OLED on it which is connected by I2C. I've got this shield that I designed which has a power supply connection on it and PoE support, so this can be powered over PoE. So I can put this into the rack and then PoE power this little Pi, and it can show its IP and everything on the OLED. I've got to put a button and whatever else in there, there's going to be a button in there. When you press it, it'll tell it to do a clean shutdown. So yeah, that is currently what my mess around Home Assistant installation is on. As you can tell, it's not doing very much right now, but I'm going to get that powered up so I can continue messing around with it and setting it up, and then at some point I'm going to migrate Home Assistant to a more grunty platform. Although maybe this will do. If I offload all of the AI stuff to another machine, then running it on the Pi is probably okay, but I would probably want to put an SSD on it, not use the SD card, which it currently is. Cool. Andrew said, installed FCP once, but it crashed when exporting the video exactly the same as iMovie did, so I uninstalled it and got a refund. Oh, that sucks. Yeah, I don't recall any particular instability with Final Cut Pro. I think it's been solid stable for me as far as I can recall. So yeah, I actually do want to move to Resolve, Blackmagic's DaVinci Resolve, but at the moment Final Cut is what I have. That's what all of my libraries are in, so I will try that. I will continue using that until there is a reason to switch to Resolve. Jordan suggested Livestream the lab tour. Yeah, I could do that. Livestream is just like being on a Teams call. Do it every day, says Simon. Yeah. It's a Teams call except that I can't see you. That's frustrating. And Any Mule said, Livestream, you don't need to listen to yourself repeatedly as you do editing a recorded video. Yes, that actually is something that really throws me. What I hate, like right now I am streaming, there is a preview of myself so I can see, what OBS is broadcasting, whether it's screen capture or face cam or overhead camera or whatever. But I'm not actually sitting there staring at myself, and that makes a big difference. I hate sitting in the editor looking at my own stupid face staring back at me and like scrubbing backwards and forwards and hearing my own voice and then, you know, trimming and editing and all of that sort of thing. If someone else was editing my video, I think it would be a whole lot better. Dentistry said, Nerd Brag, I'm exhibiting at a trade show week after next. Engineering design show in Coventry, UK. First time as my own company. Congratulations. Actually, I saw something on... did you have something on LinkedIn just like within the last week about your robots being somewhere? It's hazy, but I vaguely recall something about your robots being at some event or, yeah, something like that, which was very cool. Donna said, what's the hat? Oh, the hat, it's just called the Volt hat. It's a very simple little voltage regulator which brings up the PoE pins from the Raspberry Pi, so, and then regulates it and then sends it back down onto the Pi at, what is it, 5 volts. Yeah, it sends it back down to the Pi at 5 volts. Yes. Oh, Tabray says, I want to learn Caden Live, just mulling over starting a YouTube channel. Oh, I tried Caden Live a long time ago. KDE, whatever it is, KDE and Live, Caden Live. And I couldn't stand it. But that was a long time ago. I don't know if it's got better since then. Personally, if I was starting now and I didn't have any investment, like time investment in a video editing platform, I would go for DaVinci Resolve. It gives you like all of the pro grade features for $0. No limits. Like it's not like a hobbyist limit restricted license. It's like, no, get the full thing free. So yeah, that's really cool. Yes, JC said, yes, new robots for the show on my website now and on Robot Shop too. Cool. Oh, that's so cool. So you got Robot Shop as a distributor. So Robot Shop, for those of you who don't know, is a distributor in Canada. I don't know if they've got locations anywhere else, but they, Robot Shop, they are, I will pull it up. In fact, let's, accept all cookies. Would you like to change your current store to Canadian currency? Seems you are located in Canada and international. Nah, leave it as Australian. So I do have an account on Robot Shop. They used to sell my stuff. So let's find, I'm just going to search for dentistries here and see what happens. Hopefully it finds something. No results. Damn, how do we find your things, dentistry? Currently only in the UK. Good website though, and very good in the seller end too, which is good. Okay. Andrew said the video source was from security cameras. This is the issue with exporting from Final Cut Pro. Would play back fine, including an iMovie, but had subtle corruption. So wrote a script that checked the file with FFmpeg and recompressed bad ones. Good. That sounds handy. Robot Shop. Oh, is there a UK Robot Shop? robotshop.co.uk. Oops, not .u. UK. That one. No. Okay. All right. In that case, dentistries. I'm determined to give you a plug somehow. Dentistries. So, recent news, tutorials. Giant eye kit. That is cool. Oh, spooky and cool. Giant eye kit. Are there any videos of this running? Next gen eye kit. Paul! Welcome, Paul! So, here we go. I'm going to chuck this in the chat. Giant eye kit. Everybody should go out and buy a giant eye kit. Here we go. I'm going to move the chat up to here. And there. And there. Cool. Engineering design show. Oh, is this the thing? Okay, so you're going to be exhibiting at Coventry Building Society Arena and showing off Next Gen Leo. Haha. Nice. Put it in your pumpkins. Says JC. Yeah. So anyway, cool. That's really good to see that you have been you've been busy and turning the dream, the goal, like the what started as a hobby into an actual sustainable thing. I really wish you all the best with that. I hope it's super successful. That is really cool. So Scott says, I need to mount one of those in the middle of my front door. Yeah, with just the single eye looking around. Okay, hang on. I need to take some more caffeine swigs without you hearing the gurgling. Caffeine all gone. Very sad. Right, so now I am going to get into the actual topic of the day, which is Testomatic, and I'm going to do it in a very backwards way. Aha, Simon, self-medicating again. Yes, self-medicating with the caffeine. So normally when explaining a problem, the best way to do it is to start with the big picture and what it is that you're trying to do, and then narrow down the focus to show some context and then the specific problem that you're trying to solve, so that when people are trying to help you, they know what you're trying to get at. I'm not going to do that. I'm going to do this totally backwards. I'm going to start with the most specific thing and then slowly zoom back out to give context. There are many pieces of this puzzle where I need help because my brain is not big enough to deal with the situation. And what I'm hoping is that I can nerd snipe all of you into helping me solve these problems. So I am going to start with the most specific thing and then show you why I am trying to do that thing. I'm just in the process of opening Fusion. So I've got Testomatic and IOMod. This one? Is it this one? Hang on. Why have I not got... where is the thing that I was working on yesterday? Did I not save it? That would be very strange and annoying. Is it in here? IOMod SW? No, it's not there. Okay, that's all right. I can easily recreate this. Although it is a little bit baffling. Oh, that's in the wrong place. Okay, I'm going to delete that. Delete. I know you can't see what I'm doing, but you can just be quiet and look at something cool on on dentistries. There you go. Gaze into those eyes. Okay, so that, and then I'm going to go back out to here. I'm going to make a folder and call it IOMod MCP 23S08, and then, okay, I should probably be doing this where you can see it, shouldn't I? Otherwise I'm just talking to myself. And I do that the other, how many hours are there in a week? I can't remember. 7 times 24. Someone, was it 190? No, not 192. It's 168 or something. I can't remember. Anyway, whatever the 7 times 24 minus 1 is, no, minus 2 because I do 2 hours, 168, yeah. So the other 166 hours of the week, minus the ones that I'm asleep, I'm talking to myself while while doing things. So this is just normal. Okay, I will show you what I've done, and then you can scold me for it, and then we can all have a little cry, and then we can come up with a better way of doing it. How about that? That sounds like a good plan to me. So, I was editing this. That was remarkably dumb of me. How can I undo this? Where is history? Where is history? I can't do an undo from here. So, where is where do I get to history in the Fusion thingamajigamy? Because where is it? Where is it? Where is it? Switch view. No. I wonder if it's in the project. What I really should do is put actual show text commands. What I really should do is put, maybe I've got to do it through Fusion Online. I suspect that that is the case. I suspect it is. There was an article on Hackaday years ago where a hush puppet would stand up when your friend came online. Yeah. Right, okay. Sorry. I will explain what happened. I know exactly what happened now. This is all starting to make sense. Okay. What I've got here is, I'm going to come back into here. This is the IO mod, and specifically this one, the version 2. This is the one that I finished a few weeks ago. What's the mod date on that? 26th of the 9th. Yeah, so a few weeks ago. Oh, yeah, that's not actually last time it was done. That was because that's when the file was saved, but it's not when the release was done. So this is the IO module with the AD, it said it there a second ago, the AD5593R I2C IO expander on it. And this is the one that I'm probably going to mostly use in Testomatic. DigiKey, I'm just going to come along to DigiKey and show you something that made me cry when I saw it. DCs and DACs. Yes, here we go. Here we go. I'm going to bring this up to here. All right, AD5593R. Look at these prices. Well, that's the, what is it, a 16LF CSP? What the hell is that package? I don't think I've ever heard that package name before. It just looks like a QFN. Why do they have to invent a new name? So it's a 16-pin LFCSP. What does LFCSP low flat C, I don't know, something, the P would be package. I don't know. What does LFCSP stand for? And this is an LWCSP, which is like a BGA. Why don't they just call it a BGA? It's a 16-pin BGA, so call it that. So here we've got the 16 TSSOP, and this is the one that I've been using on my modules. But yeah, they're all in the $17 region in single quantities. And to get it down to like the $8 region, you've got to buy 1,500 of them. So that's like a $12,000 reel. And I don't need 1,500 of them. Lead frame chip scale package. Fine chip scale package, right. LFCSP is lead frame chip scale package. Okay. I don't see why they don't just call it a QFN. Maybe there's a difference. I don't know. So anyway, the sad thing is, like if I come into this one and look at the price breaks on this, at 10 of them, it's $11.83. Now, admittedly, the price does fall fairly rapidly once you go from 1 to 10. It goes from $17.33 down to $11.83. Then you get to 25 and it goes to $10.39. At 100, it's $8.77. That's still $900 worth of chips. So it's an expensive module. Making one of these little modules, this little baby here, is expensive. Like if I had to make these and sell, like if I was selling them, which I probably am going to end up doing, I'd probably have to sell them for about 25 bucks per module just to cover myself and not be making a loss on it. So yeah, they are cool, but they are expensive. And if you need a few of them, it's going to end up being hundreds of dollars worth of modules just for the I/O modules. And what they do is probably slightly overkill for a lot of testing scenarios. So this is and it's incredibly simple. I mean, look at this. It is the chip. The AD5593R does everything. It's got the dual power rails. It's got all the goodness in it. It definitely is like a universal solution to an I/O chip. It's just that price. That's what the killer is. It's the chip on its own, a pull-up, an optional address line, some decoupling, and that is it. That's all that's on the module. So what I set out to do was design a version of the module. In fact, what I'm going to do is, so that I can go back in time on this other one, I'm going to close this one off. And as you saw, there was no level shifting or anything required on that because that particular chip is designed to have two power domains. One for the I/O pins and one for the logic interface where you control it. But very few I/O chips are like that. So we need a way of connecting I/O chips that does optional level translation. And what I'm going to do now is, before I do anything else, because I don't want to screw up my design history here, I'm going to come back out to here, go into this folder. I'm going to create a new electronics project and link the schematic, and then I'll explain just how I managed to screw this up by editing the wrong thing. I was obviously in a state of haze yesterday. I did something stupid. I done screwed up. So before I screw up further, I'm going to save this and I'm going to call it MCP23S08 V1.0 in that folder. Yeah, that looks right. So now at least I have a copy of it that I can mess around with without killing anything. All right, I'm going to close that so I can see more of the tabs, and then we will come back to this one. So this is a version of the I/O module. I actually had this totally complete yesterday, and then I screwed it up. This is a version of the I/O module with an MCP 23008 on it, and that should be something that, and it should be version 1.0, and that should be something that pretty much everybody here in the stream is familiar with from my previous rantings, and from Austin in particular has used the MCP 23017 in a few projects, like in the light switch project. We use the 23017, which is basically just the big version of this chip. This one has a single port. It's got port A, and it's got 8 bits on it. So each of these pins can be a digital input or a digital output. You can't do analog input or output. You can only do digital with this. But it's an I2C I/O chip. With the 23017, it's got 2 ports, so it's a total of 16 I/O pins, not 8 I/O pins like this one. But I only want 8 I/O pins, so this is the little scaled down version. It comes in 2 different versions. There is the 23008, which is I2C, and there is the 23S08, which is the SPI version. And obviously the difference is whether it's I2C or SPI. Now, what I did yesterday was totally design a version of the I/O module based on the I2C version, the MCP 23008. And I got it to the point, it's actually, the files are actually uploaded to JLC. Like, I produced production files, uploaded it to JLC, got ready to order, I haven't submitted order yet. And then I thought, okay, now I'm going to do a version with SPI as a way of verifying that the pinout for the I/O mod is suitable for SPI based I/O chips. Because there are many situations where you might want high speed I/O. You may, because I2C I/O is not particularly fast, and you might want to have something like a high speed or a high precision ADC. Maybe you want to stick like a 20-bit ADC on there and use SPI to talk to it. So I wanted to do a version of a module with SPI. And instead of creating a new project and then migrating, like taking a copy of the I2C version, I just directly started editing the one that I'd already finished, and I screwed it up. So what you see here is the I2C version of the project with the 23008 replaced with the 23S08, because I actually began the process of converting it over. And so now what I need to do is go back in the revision history of this project to the point before I started doing that changeover. So I am going to ignore this for now, and I am going to close it, because what I'll do is do that rollback some other time, maybe after the stream. And instead, we will look at this copy that I just made, and this has the 23S08 on it. So what you can see here, see how these nets are not connected? The reason for that is that previously in this version, in fact, what I can do is go here and ICs, and I'm going to go MCP 23008, QFN, that one I'll do, stick that in here. Now, these two versions of the chip are very similar. They've got the same I/O here, and they've got VDD, reset, int, that's all the same. The difference is that the S version has MOSI, MISO, clock, and chip select, and the I2C version has SDA and SCL. So previously, when I had the I2C version of the chip here, these two signals, in fact you can see, it's SCL and SDA. These are level shifters that were going to SCL and SDA on this chip. And because I2C is relatively slow, like it might be 150 kilohertz, something in that region, we can get away with this level shifting method. And this way, what happens is that the chip itself can run at either 3.3 or 5 volts, or something in between, anything within the range that chip runs at. But the side that connects to the host device will run at whatever the voltage of the I2C bus for that device is, because we are abusing these little MOSFETs and we are pulling up the internal side to the voltage that the chip is running at. And so, oh, Wagonload says, John, can you download the original version PCB from JLC? Oh yeah, I've got that. Scott says, you may recall from last week my comment about making an archive every time I send a board for fab. Guess why? Yeah, that is what I do. But then I started editing the archive. Yeah. In fact, I'm going to, let's see, Dropbox. I have, yeah, look at this. This is a folder that I have in Dropbox, and it's the Gerber's folder. Every time I generate production files out of Fusion, I generate them and dump them into the to order folder. And you can see here that there are some that have been sitting. These are these have been sitting here since January last year, and they haven't been ordered because back then I was working on the light switch project and they've just never progressed beyond that point. And here you can see IO mod MCP 23008. This is the production files for that. Now, I've already uploaded this to JLC. Actually, maybe I didn't. I'd have to look in the JLC interface. But what I do is, if it has not been ordered, it sits in this folder. So this is production files for that board. And then as soon as it's been ordered, I drag it into archive. And you can see that archive, 60.7 megabytes, is big. That has got, in fact, I'm going to open it off screen now, 425 items in it. So that's the board production files. Yeah, it doesn't give too much away, so I will bring it up and show you. Sorted by what? Yeah, so you can see in here, like 2nd of July 2020. We got something in here from 2021. Something AntBrain there from 2018. So here I have an archive of every single set of production files that I have sent to production in the last few years. And as you can see at the bottom there are 425 of them. So I haven't lost those, because the whole point is that if I've ordered something, I need to be able to recreate exactly what that thing was at the point it was ordered, so that I never lose that reference. Yeah, so 425 board orders that I've done in the last few years. But that's not, yeah. When I say 425 board orders, that is 425 distinct sets of production files. Once boards actually go into production and I have multiple, if I'm doing multiple orders, I don't bother re-uploading. I take them from JLC's history and then I do a reorder. So I've actually placed far more PCB orders than 425. That's just how many distinct designs I have placed orders for. Scott says those are just archives of the production files. I archived the entire project folder. Oh, okay. Yeah. Can't edit that, says Scott. That is right. Grant says that is why I have daily snapshots on my NAS. Yep. So the other part of this is that I also export in Eagle, and because I want to be able to do the pick and place this is slightly off topic, but anyway, it's kind of interesting, and off topic is what we do here. I will find something else in Dropbox. Okay, I'm going to find, I just need to find things that I can show you on stream. So in Superhouse projects, in fact, what I'll do is I'll find Testomatic hardware. Yeah, here we go. So what I do is, so Fusion stores the projects in the cloud and it versions them. So every time you hit save in Fusion, it versions. And I can roll back, so I can actually get that other one back. But what I also do is export. So for example, here you can see 3 files. This is stored in Dropbox. You can see that this is for Testomatic version 2.3. So I generated production files and I sent those off to JLC for production. And also out of Fusion, I exported the version 2.3 board file and the schematic file, which is like fully editable. They can be imported into Fusion. They can also be imported into KiCad. That's one of the reasons that I export them in Eagle format. Even though Eagle is kind of defunct now, the Eagle format can be imported into KiCad. So they could be brought in and edited again. And the F3Z file, that is a complete compressed Fusion project as a snapshot at that point in time. So I could import this file back into Fusion as a fully edited project, a fully editable project. So I do have those snapshots for each of the versions of the Testomatic boards that have gone to production. So I've got an archive of the production files that I generated and an archive of the Eagle and Fusion format files that match those PCBs. No, I do not want to do that. Wagonload says if you use KiCad, each save creates a new zip file. Yep. Scott says, if a Superhouse stream ever stays 100% on topic, the world will end. Yeah. Yes. Okay, so this hardware is also in the context of the project folder, which has other stuff as well. So F3D files, you can see I've exported Fusion 3D files for the mechanicals, firmware, and all sorts of other stuff is all saved in there. This is all stored, and I also Git this. So this is also in Git, and then typically also pushed to GitHub for most, well, for all of my own public projects at least, it's also pushed to GitHub. So it would actually be remarkably hard for me to lose access to a project. Like Dropbox would have to die, GitHub would have to die, my local computer would have to die, the computers that are synced off it would also have to die. So yeah, I think I'm fairly well covered. It's just this particular stupidity was me shooting myself in the foot yesterday in my addled brain state. So anyway, now, okay, so Doing this stupid MOSFET level shifter trick works with I squared C at 150 kilohertz, but, or maybe at 400 kilohertz or whatever you can run this thing at. But what it does not necessarily do is work for SPI at, 10 megahertz. SPI can be in the, SPI can run slow. Like there isn't a lower, I think in the spec there isn't actually a lower limit on it. You can run it quite slowly, but yeah, ideally the whole point of using SPI is to get higher throughput. So this little stupid level shifter trick is probably not going to work. Now, one thing that I thought would be interesting would be to set this up with a signal generator just on the bench and feed a signal in one side and put the scope on the other side and then slowly crank the frequency up and see the point at which this falls over. And I have a feeling that it would be at a relatively low frequency, like it'll be in the hundreds of kilohertz range. I don't think it'll be in the megahertz range. David says, quick, run another backup to a different device. Stat for all your projects. Now. Yeah. So that, but I don't, where are we? Okay. But I do not believe that this is going to be a practical way to do it. There is also a bit of a space issue, because what we need to do is, now, with the interrupt output that comes from this is on the MCP 23 series chips, the interrupt is configurable. You can configure it to be like an active low interrupt, an active high interrupt, or whatever. But I'm using active low as the convention on Testomatic. So the all of the interrupt lines are shared. They come in on a shared connection. So what I'm doing here is putting a little signal diode in series with it, which means that if, for example, we were running this chip at 5 volts and it was plugged into a Raspberry Pi with its interrupt pin going to a Raspberry Pi I/O pin, we are not going to try driving 5 volts to that I/O pin. It's only ever going to pull low. So it's basically like an open collector type connection where it'll pull the interrupt pin low, but it can never drive it high. And then you need like a high bias or something on the interrupt line, which would be there already. So that's easy. The interrupt as an input, we can solve that with a diode. The reset, we also run through a diode because it is active low driven from the carrier, like the device side. And we've got a fairly weak pull-up resistor on our side here because we might be pulling this to 5 volts, the reset being pulled up to 5 volts to allow the, maybe I should put a capacitor on that. Okay. So pulling reset high on the I/O chip, and if we want to reset it, we can drive this low on the other device side, and we will reset the chip. So once again, it's like an open collector, but on this side, on the left side of the signal in this case. So both of those cases, the reset pin and the interrupt output, can be handled very simply with a single pull-up resistor and 2 diodes. I don't think there's a problem with that. So then we get to MOSI, MISO, clock, and chip select. And all of these also need level shifting, but they need to be fast. Now, what are the comments? Wagonline says, if this chip has a speed limit, can you design your own version of chip that runs faster? Potentially. Well, that's what the Serial Wombat is for. That's a whole other thing. Scott says, I don't lose data these days, other than simply forgetting where in hell I put it. Yeah, that can be the problem. So Now, what I need is 4 level shifters. I need chip select, clock, miso mosi, and they need to be high speed. Like, I think the 2308 does up to 10 megahertz. I can't remember. Where is it? I actually have its data sheet open here somewhere. I have so many windows open at the moment because I've been looking around at all of these things. Not there. All right, I'm just going to consolidate some some windows into tabs so that I can bring them up here. And where is the data sheet for that? I don't know. Not there, not there. All right, I'm going to find MCP here. Okay. MCP 23008 datasheet. Bring this one up. All right. So running at for the SPI version up to if it's anything above 2.7 volts, you can run at 10 megahertz on SPI, and below that you can run at 5 megahertz. Because this is pretty much always going to be running at 3.3 volts or above, it means that we could conceivably be driving this at 10 megahertz on SPI. So I need some kind of a level shifting solution right here, a 4-channel level shifting solution that is going to work at 10 megahertz. And that is the rabbit hole that I went down yesterday. I was looking at looking in here, DigiKey, level shifters, different options. Anyway, some options include this one, which is this is the dual or the single channel? I can't remember. Oh yeah, that must be the dual channel. So this one is a dual channel buffer. And so you can see VCCA, VCCB. There's a direction pin because you can pass data left to right or right to left, ground pin, and then A1, B1, and A2, B2. So this is just a very simple little buffer. You give it the 2 voltages, it passes stuff between them, and it'll easily exceed the data rates that I need. So at 3.3 to 5 volt level translation, for example, it'll do 420 megabits a second. So the so this is an option. The only problem is, look how horrible this package is. So this is like a little 8-pin BGA, and if we look at the geometry of it, they're also not particularly cheap. I mean, they're kind of cheap, but not super cheap. They're in the order of a couple of bucks each. Now, ignoring this one just because it's too big, I couldn't physically fit that on the module, which means I'd have to go for the QFN format. Look at this. The entire package is, just using the averages here, 1.9 millimeters long by 0.9 millimeters wide, and in that space it fits 8 pads. That is annoying. Very annoying. That would totally suck to work with. So yeah, I have worked with packages this small before. I just don't like it. Now the thing is, the pitch is actually not that bad. It's 0.5 millimeter pitch. And I work with 0.5 millimeter pitch and 0.65 millimeter pitch parts quite regularly. So that's not really the bad thing. Well, it kind of is. It kind of is, because the difference is I normally work with pins. like 0.5 millimeter pitch pins coming off the body of a part, which means the pads they go onto are exposed and they are long, like they're rectangular. They're not a dot or a hole. With this, the aperture in the stencil, so this is 0.25 of a millimeter from the center line to here. Each of these is approximately a 0.2 to 0.25 millimeter diameter hole. And you have to get solder paste through each of those 4 holes onto the PCB. And because it's round, the actual surface area of that hole is tiny. If it was 0.5 millimeter pitch, but they were rectangular pads, that is so much easier to get solder to go through the stencil and to separate from the stencil when you lift it up. But as a 0.2 millimeter hole, and you have to then get the solder to go through it and then stick to the PCB and not be lifted with the stencil, that is really, really painful. So I don't like the idea of using a package that is quite that small. Wagonload says, is that package the size of an 0805 resistor? I think it's a little bit smaller than an 0805 resistor. Actually, how big is an 0805 resistor? 0805 resistor dimensions. Let's see. 0805 resistor dimensions in... yeah, we want imperial 0805 in a metric size. So 0805 is 0.08, yeah, well, it's in the name. 0.08 by 0.05 of an inch. What is 0.08 of an inch in millimeters? Pete says 0805 is bigger than my brain. I highly doubt that, Pete. However, I am confident that it is bigger than my brain. Reflow soldering. Okay, here we go. This actually is a... I've got to find the thing. Here we go. Open image in new tab. Here we go. This will give some idea. Now, move this back over here, and I want to zoom in. So 0402, an 0402 part is 0.6 of a millimeter by 1.7 millimeters. It is somewhere between an 0402 part and an 0603 part. So what's the dimensions of an 0603? 2.3 by 0.8. So yeah, by 0.8. It is in between an 0603 and an 0402 part in dimensions. But it has 8 pads under it. So just let that percolate in your mind for a little while, because it is painful. If you look at the size of an 0603 part and imagine trying to put 8 pads under it, that would totally suck. And this is smaller than that. Yeah, so that's enough of a rant on that. This, in terms of functionality, 2 of these on the board would do what I need. So, Wagon Loads asks, can you apply solder paste on those small pads using your P&P and a hypodermic? Not accurately enough. A stencil would do it more accurately than a hypodermic type thing. It'd be very hard to apply with a syringe. The tip of the syringe would be bigger than the... it is a little brain bending. Once you get down to these sizes, Crispian said, surely this challenges the limits of soldering tech. Not for mass production facilities. They deal with this stuff. And for them, this is just like another day at the office. Like if you're making phones or anything super small, this sort of stuff is normal. They would have parts that have this geometry, but with 100 pads under it, not 8. So not, I don't mean within the same physical size. They would be physically bigger than this. But if you look at this pitch, 0.5 millimeter pitch between pads and pads that are 0.2 of a millimeter, imagine that same grid but scaled up, so it's got 100 pads under it. That's the sort of thing that you need to be able to assemble if you're doing things like mobile phones. Tabraya said, would this need stencil openings? Surely the chip is BGA with the balls attached to the chip. Ooh. Yeah, Stephen W says 0.5 is on the larger end of BGA. Yeah, it is. I've done BGA reballing, I think to 0.4 millimeter pitch is the smallest that I've ever done, the finest I've ever done. But yeah, 0.5 is like just an everyday thing for BGA. Ah, okay. So this is exactly why I was hoping to enlist everybody's help. Let's see what this does. This is, outside the box says, when do they start counting the molecules? Yeah. Well, modern electronics, if you look at the processes inside the gates of a modern microprocessor, they're dealing with statistics of electrons. It is totally batshit bananas when you start looking at the geometries that they're dealing with now. So this is a level shifter. Oh, it's an 8-channel level shifter. It'll do... Ooh, this could be an issue though. So it's a level shifter, 3.6. It would do for this use case where the host is... Maybe this would do. What this would not allow is for the module to be used in a 5-volt host. It would have to be on a 3.3 volt or lower host. Wagon Loads points out, if you think those pads are small, just think of how small the hair wires are connected on the inside of the chip. Yeah. The V is a 4-channel. You have opened the 8-channel. Okay. V. So if I wanted to go this and get rid of that and translate as level shifters, active gets rid of 1. What options do we have here? Oh, is there a V? It looks like these are all 8-channel according to this thing here. What are those? 8-channel, 8-bit. Yeah, okay. Okay, so the 4, right. Thanks, Stephen. Thanks for pointing that out. So maybe this will be the solution to my problem. Ooh, UQFN. That is much easier to deal with. So where am I? I'm going to sort by price, just cause, and surface mount wettable. Yeah, whichever. 000 stock. Let's get rid of the no stock stuff, just to narrow it down a bit more. What have I got? So this is a little BGA. So that's a 12 BGA. What's the pitch on that one? Oh, 0 stock, but it's in marketplace. Okay. Scott says, I have a 32-core Xeon chip sitting on the shelf here. Fairly certain the gates are made from individual atoms. Yeah, we pretty much are at that point. We can do almost atom level manipulation. It's just that we do it in very small areas. We are not redefining reality, except in the context of, now let's have a look at this one, except in the context of a 4 channels, 3.6 on one side, 1.6 to 5.5 on the other, tri-state non-inverted, yeah, 100 megabits a second. It's a 12 pad UFQFN, 1.7 by 2 millimeters. Let's have a look at how horrible the footprint for this would be. But Stephen, you may have found the solution to the problem. Let's find ourselves a geometry. It's funny that I go straight to the geometry before anything else. What's the pitch? Okay, so we've got 0.5 millimeter pitch, but I would much rather deal with this sort of geometry where we've got, now let's go down to the pad size. But you see how the pads are elongated? That makes them so much more easy to deal with on a stencil than a 0.2 millimeter hole. It'll release so much better. Okay, solder mask defined, solder mask. So the pads are, okay, so it's got via recommendations. The pads are 0.6 by 0.24. Yeah, I am way more comfortable with that. This could be the sweet spot. So it's 3.3 millimeters by 3.3 millimeter package. It's definitely not as nasty to deal with as a 1.6 millimeter by 0.8 millimeter package. Yeah. What was that? Oh, Scott says, I really want to get the replacement for that ship installed, but can't justify the 2K to fix a spare machine. Well, if it's only a spare machine, then yes. Oh, and look, here we are back to the horrible BGA, but now instead of 8 pads, we have 12. But it is 4 channels instead of 2. And it comes in this VQFN format. All right. So that, I think, might be what I go for. Oh, Scott says, that 8-pin BGA you're looking at, bet it'd work okay with rectangular pads. It probably would, actually. But it was only 2 channel, therefore I'd need 2 of them. And this one is 4 channel, so I only need 1 of it. But yeah, Scott, you're right. I probably could bodge the footprint for that and do something with that. But being BGA, as was someone else pointed out, it would already come with the balls on it, so it probably wouldn't need. How would I do that? I don't know. Anyway, I don't know. But this, all right, 10, 10, 25. I'm just going to add these to my cart. Add to cart. Boink. And is it going to, what have I got? What have I got? View cart. I should have other stuff in my cart as well. Request too long. What? The size of the request headers is too big. Well, it's you that submitted the request headers, DigiKey. What are you doing? All right, so I've got to make sure I don't lose this. I'm gonna do this again. DigiKey, leave that tab open, come to here, log in, orders. I'm just gonna see if I can log in because yeah, I've already got stuff in the cart. So I am now going to search for this and add 25 of them to the cart. Come on, add to cart. and view cart. I just want to make sure that it does. Oh, request too long. DigiKey, what is wrong with... now I wonder if I've got 4 items in the cart now. View cart. Maybe DigiKey site is broken at the moment. Yeah. There we go. It's added to the cart twice. So it's successfully added to the cart. It just... yes, delete. It just did not... 3080, what am I doing with that? I2C transceiver. What was this one? Oh, okay, I know what that is. Yeah, that's a IC transceiver. Yeah, that's an RS422 thing. Yeah, it's got only 144 bucks, barely anything in your DigiKey cart. Yeah, I know. It's past the it's past the free shipping amount though, so I'd probably just submit it. I often place a couple of DigiKey orders each week because it takes so little to get above the free shipping that I could just send this off now, and then if I want to order more stuff, whatever else I want to order is probably going to be more than the free shipping threshold anyway, so there'll be another order soon. Okay, now that I've got it in my cart, hopefully that will keep the reference to it and I can go back and fix up the design. So, Stephen, thank you for finding that for me. And I will close that, give up on that, and that's the data sheet for it. What's this one? Oh, that was when I was searching for level shifters. This is the AD thing. Now, if I come along to LCSC, I have in my shopping cart already, so I've just started accumulating a cart here. That's 2308s. I need to add some SO8s as well. Let's come up to here, and I want to search for that. 0 in stock. Sort by price. Give me the cheap ones. Other suppliers. Yeah, that's a third-party supplier, which is annoying. 29 to 31 business days. No, screw that. Let's just go straight for the microchip one. Oh, which footprint is this? I want the one that is... yeah, not that one. I want this one. Stock 14. No, I want more than 14. Where's the rest of them? Okay, maybe DigiKey. Let's see what DigiKey has. MCP 23S08. Do they have stock? I want it in the VQFN. Apply. And, oh yeah, they got stock. Okay, cool. $2.63, $2.63. So that's tube. No, I don't want a tube. Stick it up your tube. Don't want that one. Let's go 25 of those. Add to cart. It'd actually be interesting to see what MCP 23008. Let's see what it is at DigiKey versus LCSC. So VQFN once again, and $2.37 in cut tape. So this is Australian $2.37 or $1.90. So compare that to what I've got in my cart here. I might end up just getting it from DigiKey. This is $1.41, but that's US dollars. So this is $1.41 US is pretty much $2, and then there's shipping on top. So stuff it. I'm going to add some to my cart in here as well, and probably get both the I2C and SPI versions from DigiKey. View cart. What have I got? Don't forget the tariffs. What tariffs? I'm not in the US. So I've got the 2308, the SO8, the level shifter, and then some other things. Yeah, this is a very expensive part for a specific project that I am working on for Plasma Steve. This is part of a project I'm doing to control the tool changer in his CNC lathe. He's got a, what's the brand? I can't remember. Anyway, he's got some CNC lathe that is retrofitted with Linux CNC, and at the moment the tool changing turret can't be controlled by Linux CNC, so I'm building an interface board to connect to that, and anyway, that's the story behind that one. I will probably talk more about that at some point once there is actually something to talk about. So, shawing bada. Pete says 30 minutes. Bada bada bada, shawing bada. So, does anybody know where that's from? It randomly came into my adult brain. Come on, someone tell me the movie that is a quote from. I'm not seeing the answer. Dentistries! I'm afraid I have to go, so thank you, John, as always, and goodbye all. Well, thank you for coming along, and good luck with that show. Stephen got it right. Biola, Biola, Biola. Cameron says it. Yes, says Crispian. It was Cameron. So, close that. All right, now, I want to get onto nerd sniping you all into helping me with a couple of other projects. Other aspects of this project. This one right here. Okay. Now, I'm gonna fix up all of that. All of these IO mod things, I'm gonna fix up another time off stream, not right now. I want to talk about the other part of the Testomatic project before we get to there. So the chassis, do I have a chassis assembly model here? I think this is the most recent one. Should be, I hope. Now, what I have done is I finally got around to cutting the pieces that are required for the modified chassis design. And you may recall, it's ancient history, so it may be so long ago that you don't remember. What I said ages ago is that I wanted to increase the height of this cavity. So the distance between that line and that line, which now, after the modifications, is 38 millimeters. Ooh, Stephen just sent me a message saying to check application notes on that chip before implementing it. Yeah, that's a good idea. I will read the data sheet and go into things a bit more before I actually just hit buy now and start implementing it. So what I've done is I wanted to lower this deck in order to have more space for the test module, because that gives more options. The previous design with the higher deck required the module to be fairly thin, and that means that if you are using things like pluggable pogo pin sockets, they can't protrude down very much. I wanted to make that gap bigger so that you could use thin modules, but you're not limited to it. You can have deeper modules, and that way you can have things like point-to-point wiring underneath the module. It just makes it easier to build modules where you are hand patching things together or putting extra functionality underneath it. So that, and there was no reason to have the deck higher. So what I did was I compressed there's a power switch in that hole. That weird shaped hole, that is for a panel mount power switch to plug into. And it's keyed, which is why it's got the slot in the side. there's the XT60 for the main power in. So I compressed all of this. I also added an Ethernet pass-through connector on the back panel, and then there will be a patch lead that plugs onto the inside of that, loops around and goes onto the Raspberry Pi. Because on the current Testomatic, as it is right here, I will show you in a second, there is no cabled Ethernet option. The Ethernet on the Raspberry Pi is physically inside the box. You can't get to it. And I'm just using Wi-Fi at the moment. And in a lot of the time, Wi-Fi is going to be fine. But since we've got Ethernet on the Pi, I figured that Wagonload says back to wire wrap looms. Yes, exactly. Wire wrap is actually what they use quite often on the bottom of Pogo test pin thingies. They've got square pins sticking out the bottom specifically so that you can wire wrap them, which is very 1980s. So yeah, I figured all I've got to do is add a pass-through connector on the back panel and a patch lead, and that'll just make it so much more convenient. It means that you can plug Ethernet straight into it if you want to. Don't need to if you don't want to. You can just use Wi-Fi, but for an extra $5 for a connector, it's just a nice little, quality of life thing. Yeah, so anyway, a couple of days ago, oh, and also the cooling fan, this fan that's on here, is moved to the side. It's now on the left side. It used to be in the back, but now right here in the middle. But now there isn't enough height for it above the USB hub. So I moved it, and basically the top deck here is dictated by the height of the fan. That fan just fits between the bottom plate and the bottom of the top deck. That's like that's the thickest part of what's inside the enclosure now. And I cut the pieces and I reassembled it. You can see now that this 3D model is showing the version 2.3 board, and it is showing the new updated I/O modules. And you can also see that I pulled back the edge of the top deck a little bit here to have a bit more clearance, and that is so that it makes it easier to get the I/O modules in and out. And the deck is now low enough that you can reach in and grab those modules and pull them out and replace them, which was hard before because the deck was, I think, about 12 millimeters higher, and it was kind of halfway through the height of the modules. So it was kind of awkward. It's better now. Much better now. And that is what is... Crispian says, you might have to lean the fan inwards to make it fit like a motorsport scenario. Yes. Oh, and Scott says, but do you actually have the tools to wire wrap? I do. Yes, I do. I have done much wire wrapping in the past. Back when I was a teenager, yeah, my first ever computers that I made, the Z80 based computers, were done with wire wrap. So yes, I have wire wrap tools and wire wrap wire, etc. Overhead. Okay, let's go to overhead cam. And this is the updated tester with the new side plates. So the pieces I replaced are the side panels because the slots need to be at a different height. They were up here somewhere previously. The back panel is replaced because it needs to be lower, obviously. Fan removed. It's got the hole there for the Ethernet pass-through, which hasn't arrived yet. I've ordered them, but they haven't arrived. And you can see there the fan inside the left side of the enclosure, and it's got a temperature control PWM thingy. So if it gets hot in there, the fan will start. And the sensor, the temperature sensor for the fan control lies across here, and it sits on top of the Raspberry Pi. You can probably just see. So this black thing here that I'm just touching with my fingertip, that is the lead going to the thermistor, which is used for controlling the fan. So if it does get warm inside this chassis, that fan, like if the Raspberry Pi gets warm, that fan will turn on and it will blow air across the Raspberry Pi and will exit through the holes in the bottom vents. There's no other holes on the other side. And the whole thing sits on little rubber feet, and which gives it, I think, about 5 millimeters of clearance underneath. So the air would just come out the sides, like come out the bottom and then out. And yeah, this is, as you can see, with the new version 2.3 Testomatic board. And it is now fully populated with IO mod modules. And the touchscreen gives me control of power. You can see if you watch those LEDs. So these are the 3 power rails for the tester. So that is, like the tester itself, that is V in 5 volts and 3.3 volts. So they should all be on all the time if everything is working. And then these 3 LEDs are the power rails passed through to the test module. And that is V in 5 volts and 3.3. And I can control those through the touchscreen now. So I'm going to turn off those power rails, and you can see the LEDs. You would have heard the relays clicking as well. So the power rails to the device under test are now fully controllable from Node Red, which is what's running this touchscreen. And I can turn those power rails back on again. So if I grab a, I'll turn them all off. If I grab a test module, plug it in, you can see that it has the 3v3 and 5 volt rails on there, but those are for the, those are the tester power rails, not the device under test power rails. And then I can turn those on from there, and it comes up on those LEDs. So we're now in a situation where the chassis, apart from the clamp mechanism that goes over the top with the pressure plate, is pretty much complete. I've got holes in the sides here for the gantry that's going to go up for the pressure plate and the clamp, but I don't have that on here. I've designed it, it's in Fusion, but I haven't actually made it. I will get to that one day. But the chassis itself is pretty well complete. So now I am in the situation where I have to fix the software, or I have to finish the software, or at least make the software kind of work. What I can do now is I can select a client, so I can say it's Superhouse, and the device is going to be a Rack32. I can put in the serial number, I can click start, and it would flash, like if I had a Rack32 connected to it, it would then flash the firmware onto the Rack32 and do whatever testing needs to be done. So you can see on the test module here, there is a chip up in this corner. I'll turn off those power rails again. So you can see there's a chip. That's an EEPROM, which allows, in theory, the Raspberry Pi in here to identify what test module we've plugged in. So if I unplug the test module, take it away, and plug a different one in, we could have the Raspberry Pi query the EEPROM and find out what module is installed. And that would save having to select the target board off the touchscreen. It would just be fixed based on the module that is plugged in. So now, where are we? Pete says, Steve and Steph, proof of life, please. Yeah, because I haven't done this for so long, I will bow to pressure. I will bow to pressure. Steve and Steph are right here. They live up on the shelf, just up to my right, judging me, looking down at the stupid human and wondering what I'm doing. Yes, so Steve and Steph are still alive. So there were a couple of quick questions about thermals. And Scott says, thought about airflow control to guarantee that our pie gets cooled. Wagon Load says, is there a web interface to set the fan thermostat trip level? And Crispian says, what about a shaped fan thermal response? Okay. Short answer to all of those is, haven't bothered. The pie doesn't, so far at least, the pie doesn't seem to get hot. And if I turn this on, like when I turn it on, the fan starts running. It runs for a couple of seconds because the fan controller it powers it up initially, and then it checks temperature and then it turns it off again. As Crispian said, yeah, overkill. So it's not been an issue. I am just going to find the place I got the panel mount sockets from. It was a classic AliExpress purchase. Hang on. Sign in. Sign in. Yes. Yes. Come on. Come on. No, I do not want to do that. All right. Get link. I'm going to be totally mercenary here, and I'm going to get an affiliate link. So these are the pass-through connectors that I got. Ethernet panel mount. What am I doing? Mount pass-through. And that is the one that I got. I ordered I think 5 of them. So it's $6.22 Australian, and because I ordered 5 it was free shipping. And it's basically just 2 Ethernet sockets back to back. And you can see you can see from that picture there. There's an Ethernet socket on the front, Ethernet socket on the back, and then what you do is you get a little Ethernet patch cable on the inside. You plug it into the back of the socket and plug that into your device, and that then exposes Ethernet on the panel side. So nothing super special, and there are different styles. Like there are these one. Was this US RJ45? Yeah. So these are round ones with a screw thing on it. Cat 6, that's so 2002. Yeah, and as Crispian says, short as possible. Yes, probably something like a 15 centimeter or a 20 centimeter patch lead will go on the inside there. It'll be very short. Scott says, it reminds me to find or design a Keystone panel mount. Yeah, I've got Keystone. That is actually what I was first going to do. My original plan was, on the back of this, I was going to just design it so I could snap a Keystone connector into here, and then I realized that I would also need some kind of a 3D printed thing for it to go into, and then I found I could buy these ready to go for $6, and I thought it wasn't worth my time to mess around with designing a Keystone mount when I could just buy the things ready to go. Yeah, these are ready to just screw in. And I just made a simple 3D model of it based on the dimensions that are on the ad. All I did was look at this and got some dimensions off that, guesstimated some things because it doesn't actually tell you things like the hole sizes. I'm assuming that that is an M4, I think. I can't remember what size I made the hole. Might be M3. I don't know. And so I just designed a simple 3D model for the connector, just purely to make it look a bit more complete when I stuck it in the model. And now, all right, let's zoom out rapidly because I want to nerd snipe you into Oh, hang on. Keystone mounts are just a rectangular hole, says Jack's Tech. They kind of are, but it depends on the thickness of the material as well, because the snap little thing, there are, anyway, what it came down to is the 4.5 millimeter acrylic that I'm using for the back panel here. If I just cut a rectangular hole in it and snapped a keystone jack into it, I think it would have ended up rattling around. It wouldn't have been like a nice snug fit from the, yeah, and also it doesn't look that nice unless you put a cover over it. So yeah, anyway, that was it. Yeah, it just needs a square hole, yes, but to make it nice, you need more than a square hole. You need a square hole and a spacer and stuff. And I don't think it would end up looking as good as one of these ones. We shall see, we shall see. But yeah, keystone is definitely a way to do it. Now, what I need to do now that I have this device, so this device essentially complete, I need to start doing software. And there are different levels. There are layers, Jerry. There are layers to this software. One layer is the driver for the AD5593. So the low-level thingy for the actual I/O chip. Then there is some way of being able to interface with that from the test software. Then there is the test software itself. Cable tie. I can't believe it. Cable tie is here. Zippy, says Scott. Yes, g'day cable tie. Cabletti is here. Now, so, I had a whole lot of questions for you all to answer for me. Now. Okay. How to structure. All right. Imagine this. We've got, Stephen said USB-C panel mounts and others from the same seller. Okay, with a link. Nice. And with 3D models as well. So I didn't need to bother making my own 3D model. Oh well. Okay. Keep in mind that these modules are going to be replaceable. It might be an AD5593R based module. It could be an MCP23008. It could be a 23S08. It could be based on Serial Wombat. So what we need within the code that runs the tests is a way of talking to these modules. And it needs to encompass the driver for the module and also a little bit of wrapper functionality, because right up here we have the I2C multiplexer. Now, each of these modules is on its own dedicated I2C bus, and they are connected into this multiplexer, which goes to the Raspberry Pi. So, what that means is, imagine you have a test scenario where you have an I/O module here, and you have got these 8 I/O pins connected to pogo pins that are connected to your device under test. And in your test, you want to, say, simulate a key press. So you want to set one of these pins as being a digital output. And then you want to use another pin to measure a voltage on an output. So you want to see whether your key press has triggered the device to react in a certain way so that you know if it's working. So effectively what we need to be able to do within the test running software is to specify, I want pin 0 to be a digital output, I want pin 1 to be an analog input. And when you drive it, you need to do a couple of things. What you would do is set the I2C multiplexer to the correct channel for that module, and then you would drive that pin. And then you might read from this pin, or you would you might be doing this across multiple modules. So effectively what we need is a wrapper. This is just what's going through in my head, and maybe people have got a better idea than this. What I'm thinking of doing is having a wrapper where, in fact, maybe I should write this down. Oops, no. I just typed sub enter, and of course it's open subsurface again. No, I do not want to get stuffed. I do not want to run subsurface. I do not want to do scuba diving logbooks at the moment. Sublime test. Sublime text. Okay, here we go. Sublime. Sublime. Give me a new tab, and I am just going to start writing down my stream of consciousness thoughts right here. IO mod driver library, and I should have started doing this in Markdown, but anyway, I can fix it later. How about I just do this? That'll do. All right, now I want to have drivers for, and this will be AD5593R. And of course this list is going to change. 23008, MCP 23S08, Serial Wombat. So these are particular targets that could be the modules. Then we need to do something like, if we make this an object-oriented interface. So okay, I'm just going to brain dump out of order here. It's going to be a Python library, and it's going to create an object and specify the let's see, driver as above, and then we want to, oops, not that, as above, and then we want to specify the slot, and that's going to be A to, what do the slots go to? A, I'll count on my fingers, B, A, B, C, D, E, F, G. So it's going to be A to G, and then it will expose a pin number, and that'll be 0 to 56, I think it is. I will explain a little bit more about that in a moment. Then methods to set pin type, and that's going to be dependent on the capabilities of the module type. Drive pin and read pin. All right, now to explain what I'm thinking here, we would do so Wagon Load says, can each IO mod be ID'd by its I2C address? A little, kinda, but the addresses will typically be the same. They're just on different slots. So it needs to, I will add in here, control I2C multiplexer. Multiplexer. Or multiplexer. So the sequence would be that you would instantiate an object to represent a module. A module, and then you would be able to set it up so that it is, you know, for example, that it is, so you'd give it a driver, you tell it what driver it is and what slot it's in, and that should be enough. Then, oh yeah, and as Pete says, don't forget to dislike and unsubscribe. I'm going to have to send my my 100k subscriber plaque back soon, because I was on 104,000 subscribers for a long time, and that number is now dropping by, like, I think it's in the order of 100 a month, sometimes a couple of hundred a month, as YouTube subscribers, like, as their accounts expire and whatever happens. And so my subscriber count was clear of 100,000, and now it's dropping back towards 100,000 again. It may go below 100,000 before too long. So instantiate the object to represent a module, and then when you want to use it, I want to do something, I want to be able to do something like set a pin type, set pin type by pin ID, which will be, what is it, 0 to, oh, actually I think it's 0 to 55. 0 to 55, because I think there are 56 IO, I can't remember, however many IO pins there are. So then I'm just going to make up some pseudocode here. So it would be something like IO mod dot set set pin set pin type. I'm just spitballing here. It's pin 23. So the idea is that at this point you don't actually need to know what module it's on. You're just saying which pin it is. And, well, actually I'm going to use a lower number. I'm going to use pin 11, and I'm going to make it of type input pull up. Something like this. Okay, and then you could do IO mod dot set pin type 12 output. Oops. Oh, what am I doing? Failing, that's what I'm doing. So I don't know if I'm still mulling over whether this is a good idea or not. I'm thinking about what the API is going to look like. Okay, so my general approach with this sort of thing is not to jump into implementing the core of the functionality, because I think the core of the functionality should be dictated by what makes sense from an API point of view. So I like to do like a fake implementation first and see if it makes sense, because it might well be that we want to specify which module we're talking about, or have, actually this will be different. Oh yeah, like this could be, imagine, I'm just doing kind of pseudocode here. So we'll say new new IO mod, and I'm going to call it IO mod B, and I'm going to tell it that it is an AD 5593R, for example, and and I'm going to tell it that it is in slot B. So then down, whoops. So then down here, I would be saying IO mod B, and oops, IO mod B. So maybe using, this comes down to the convention of how these pins are going to be numbered. So that could be pin 3 on IO mod B, which would actually be pin 11 on, as an abstraction, Um, yeah, so I just want to play around with ideas like this of what is this going to look like. Let's zoom this in a little bit. Of what is this going to look like and what makes sense before getting into implementing it. So, do I want to be dealing with the I/O pins as, I think I do, as a slot and a pin within a slot, not just a direct number, because it's very easy to lose track. If you're talking about a number from 0 to 55 representing the 56 I/O pins that are exposed on the header, then and you start talking about pin number 47, it's hard to, in your brain, figure out which of those slots it corresponds to. So I think it makes sense to treat them, yeah, I'm going to say, where am I? Oops, I'm going to say here, maybe a bad idea, as a question, because I don't actually know. And it may make more sense to just say IO mod B. So we would end up with a new object that is representing that slot and then a pin within that slot. So then in the test setup, you would do something like, in the actual test runner, you would do IO mod B dot digital write 3 low, just for example. Now I'm doing this kind of in C pseudocode, but this would be, well, it's actually C++ pseudocode, but this would be in Python or whatever the test runner is written in. So IO mod B, I think this makes more sense. This makes sense. Now I'm going to get back to Lionel's question in just a second. Oh, sorry, Grant's question, which was about the level that we're thinking at here. Okay, now this is software layers. So at the top level, we want to have a definition for the test sequence. And what do we want that to be defined in? Maybe JSON? Then, why do I keep doing that? Then below that, we will have the test runner written in Python. And then below that, we have various driver modules, including, so we would have a library. So this is giving context for where this would all fit together. Library for Testomatic, including, oops, the IO mod drivers. So another part of this is thinking ahead to people wanting to use IO mods in their own projects outside of Testomatic. So I think having IO mod drivers as a distinct thing is a good idea. Paul Schultz says YAML. I don't know. I will add that as a thing here. Okay. This is conceptually kind of how I'm thinking about it. Even though the test sequence, now, the test sequence may actually have to be more Python, because there may have to be all sorts of conditions within this. And we will get to that. We will get to that point. But what I'm wanting to do is look at the context of the drivers for dealing with the low-level I/O modules have to be at the bottom level, because they are dealing directly with the hardware. They are driving outputs, reading inputs, and then reporting it back up the stack to whatever it is that's doing it. So the definition of the test and the test runner will be fairly tightly coupled together. And a design goal here, in fact, I'm going to make this explicit. Design goal, make the test definition as thin as possible. Test definition, as thin. I type good. Even on this fancy keyboard, I still can't type good. Make the test definition as thin as possible, but allow conditionals, etc. So it's not just necessarily a sequence of things to do. We have to define things like, I want to drive this output that is going to the device under test, and then I want to check the response of the device under test, and depending on the response, do different things. So it may actually need, the actual test sequence may require logic in it. It may require loops and other things. Oh, excuse me. The coffiness got me. Yaml, you all must leave. Yeah. Okay, so Wagon Load says, if it was a web template, I would make each IO mod socket a separate PHP module, including file that would have all of the parameters for that specific module. Then I hit a link that plugs the file I want in each slot. Okay, yeah, that is a good way of thinking about it. So that's actually, oops, there is the question of whether this needs to be split into multiple other layers, and I think it probably does. So library for Testomatic, and that which loads driver libraries for IO mod modules. So you would have you would do, in Python, you would do an include Testomatic in the test runner, and that would, you could then do include, as separate files, you would have drivers for the AD5593, a driver for the MCP, blah, etc., which could be separate. Cable Tie said, just tried to move one of John's windows aside. Yeah. Which one were you trying to move out of the way? Yeah. I do that sometimes in screenshots. Like if I've got a screenshot of my whole desktop with multiple windows, I will try to move a window inside the screenshot. So the okay, now questions for you. One is, what should be used to define the test sequence? And if it is some, how much do we have? Okay, this might be a stupid idea, but the test sequence could actually be stored in the EEPROM on the module itself, so that when you grab a module off the shelf, you plug it into a Testomatic chassis. The chassis could load the entire test sequence off the module. And then if you plug the module into a different chassis, it loads it into that module. It runs it off that one, which means that the Testomatics don't need to know in advance anything about the tests. The test module is self-contained and includes all of the logic required. The Testomatic would provide these layers. The test runner, which would be the Python that executes the tests, the library that encompasses the other things and loads the drivers for the modules and things, and doesn't need to have the actual test definitions. I'm not sure if I like that idea. I'm going to put it on here. Where should the test sequence be stored? In EEPROM, on the test module, on the Testomatic, in a cloud service, pulled down based on test module type, because another part of this, of course, is the online system where the data from the test results is stored. And what we could do is have a web-based interface on the Testomatic cloud service where you define the tests. And then when you run when you boot up a Testomatic, it connects to the cloud service, identifies itself, and pulls down the test for the board that it needs to test. That way you've got one place where you edit the test definition, and if you update it, all of the Testomatics then get that updated test definition. So that is something to think about. This is actually a really important question. Where should the test sequence be stored? I don't want to make the Testomatics dependent on the cloud service, but I want to make them be able to take advantage of it. So maybe something like locally stored, but synchronized and versioned. Jackstack said, you want a running test to complete even if the cloud connection goes mid-test, dies mid-test. Yes, absolutely. That's right. I'm just thinking about this from the point of view of when you boot it up, where is it going to get the information from for the test that it's going to run? And then after that, it should be possible to go offline or whatever happens and have it continue being functional. So this follows the same basic philosophy that I use for home automation, which is that online services or cloud-based services should augment the basic functionality, but basic functionality should not be dependent on those cloud services. So if your internet connection goes away, your light switches should still work. That is the critical thing. And in the same way, if your internet connection goes away, your test chassis should still work. Like your Testomatic should still work. It just won't get updates of revisions to test sequences and that sort of thing. Yeah, I'm a little bit behind you, Scott. So, like I said, that is what I do for web pages. I make the entire site like Lego blocks. So I change everything site-wide with a single click. And Stephen says storing Git could be GitHub, local clone, or other Git repository location. Just need something pointing to the store. Yeah. Use Git for versioning of test sequences. I'm going to make all of these questions because I don't want to just state this as a foregone conclusion. This is an open question to be resolved. Yes. So, these are the things I have been pondering over the last few days. So, I need, the next steps for the Testomatic test runner are, well, I need to get the low-level drivers working. And they kind of are. In fact, if I'm gonna, where am I? Find a, oh, I've already got one here. I'm gonna clear this and bring it up here, and then I'm going to zoomify it. So this is a shell on the Testomatic. So this is the one that's sitting on the bench next to me right now. In fact, I'm going to unplug the module that is in it and plug a different module in because I need to show you something. What I'm going to do is, so I've just unplugged this module and I'm going to plug this one in. This is a little simple breakout. It's just got a whole lot of pin headers on it. So if I plug that in, the reason I'm using this is that it means I can feed a voltage back into the reference voltage pin, like the I/O voltage pin of those I/O mods. And you can see that I've plugged a couple of wires in here. Right now you can see that for module F, it is connected to 3.3 volts, and that is just jump it across. So it'll now be getting 3.3 volts. You can see that for module D, I've got it going to the 3.3 volt rail, which is controlled by the Testomatic. So right now that will not appear. All right, now, and I'll unplug this one just to remove any confusion. So I'm going to show you something now. All right, keep in mind this arrangement. We have 3.3 volts going to module F. We have a wire in place, but we don't have any power going to module D. So now back to here. If I do, what's it called? Scan expanded, that one. All right. Now, what this has done, what this scan expanded I2C script has done, is it has gone through the I2C multiplexer and enabled each channel in turn and then run an I2C scan. So what you can see is that when the first channel is enabled, channel 0, we get device responses from hex 40, 41 and 42. Those are the INA 260 current sensors which are on the power rails, and they are directly on the I2C bus, so they are always going to respond. They will always work. You can see that when it got to channel 5, it got a response back from a device ID 10. That is the AD5593R in that module. Now, watch what happens. I'm going to turn on the 3.3 volt rail. It's going to go click. The 3.3 volt rail is now turned on. And if I run that scan again, you can see that we are now getting it on the other I/O module. So the I/O, what this is demonstrating is that the I/O mods appear on the bus when we provide power to them. And this is all working very nicely. So the we're at the point now where with appropriate drivers for the AD5593R, we can read and write I/O pins off those modules. So that is the next piece of the puzzle, and that is why I am, in fact, if I have a look at this, you will see, so this is based on an example from Adafruit. You will see that what it's doing is, so the TCA9548A, that's the I2C multiplexer. So what it's doing is creating an I2C bus, and, well, that's commented out. It's creating the object, and then in each channel, it is getting a lock on the channel, sleeping fractionally. I could actually remove that now. It's printing the channel, and then it is scanning the entire channel to find all of the addresses in it. So this is the critical bit. What we need is a wrapper for the driver for the I/O module, that when I say, for example, read from pin 12, it knows, well, okay, either I say read from pin 12 and it knows that that is on the second I2C device, it gets a lock on that channel, it reads from the pin and then returns a result to me. Or I explicitly say IO mod B as the object, and it knows that that is on the second channel. So once again, it gets the lock on the channel and then it reads from the pin. So it's a two-step thing. If we're wanting to read from an IO pin on one of these IO modules, we first have to select the channel on the I2C multiplexer, but that should be transparent to the end user. And that is the reason for this. It is so that the test runner can, or the person can define, I want to drive IO module B pin 2 high. They don't have to worry about the multiplexer or anything else. That'll just happen automatically. That'll be taken care of by the lower level Testomatic object, which knows which slot you're trying to address and therefore selects which slot on the multiplexer it is going to use. So anyway, that is basically where my brain is at right now, is puzzling over that this specific structure. I'm thinking about, at the lowest level, the driver for things like the AD5593R, but then the level above that is wrapping the driver so that it correctly addresses the multiplexer, and then above that, exposing an object to the test runner, and then the test runner executing these things, and then the level above that is, how do you define the sequence of things that the test runner is going to do? Those, my friends, are all questions to be answered. And it's not a small job, as you can see. Yeah. So anyway, I'm going to go because I'm over time. Grant says, I would think that you would want to store the test sequence in Git along with the board design and firmware if relevant. Yeah, so however this is defined needs to be representable in Git. And that's why I think something like a chunk of JSON or even Python or something is a good way to do it, because then it can just go into like a tests directory for the project and stored on GitHub or whatever you want to use. So yeah, a Git repo location, which might be a local repo. Yep. So both Stephen and Grant are on the money there, I think. Yeah. Crispian says the jumper wires are resistive enough to smoke up at about 5 amps. Yes, and I did that during the week when I was working on the e-brake for a car for the... So this is a bit of a... In fact, I've got it. Where is it? Somewhere here. Here. This is the controller out of a Holden Commodore e-brake system, which has got a CAN bus interface. You can see I've patched wires onto it. And the actual e-brake is on the floor down under my bench. So the e-brake pulls about 80 kilos, so about 800 newtons of force. It's got a big motor in it with a worm drive, and it pulls a lot of currents. A lot of the amps, all of the amps as it needs. So I've been working on reverse engineering this CAN bus based e-brake controller because Mitch from Mackie Elec up the back is needing to put it into the 1000 horsepower Mr. Whippy van so that it can be registered, like street legal. Anyway, that's a fun little job that I'm helping him with at Stephen says an e-brake under the desk for all the squirrels on the stream could be handy. Yeah. Anyway, the point, what reminded me is that I had some jumper wires hooked up to that. I was running it off a bench power supply and it melted the jumper wires. It pulled all of the amps, all of them. Yeah, those e-brake motors take a lot of power, like 20 or 30 amps or something at full noise when they're trying to exert full force onto the brake. So yeah. And Wagon Line says, can't you pull code into your code? Pull code into your code using include requests. Include test sequence 47. Yes. Oh, Donna says, got to go. Have fun this week, peeps. Yes, well, I've got to go too. I've actually got a family lunch thing. I need to go and pick up my sister and take her to meet my dad and my aunt. So I can't really stay much longer. I'm off topic now anyway, because I'm talking about Mr. Whippy vans with 1,000 horsepower engines in them. So yeah, all of this, what's on the screen now, this is my very next thing to try to figure out. Because I now have the hardware. It is sitting here, I've got the modules, I can exercise the hardware as we've seen here. I can see the devices on the modules. I just need to sort out how to wrap up the drivers for those modules, and then working back up the stack, the layer cake of how to run the tests and how to define the tests. So that is the challenge, and there might be some coding type oriented live streams coming up, which is always scary because I am terrible at it and it's embarrassing. Grant says, build a reasonable but imperfect system. Software can change. Yes. The perfect is the enemy of the good. I'm just going to try to make it work. Dan says, what model Holden for the e-brake? I have reverse engineered one in the past. I think it's off a VF Commodore. I don't remember specifically. I don't actually even know, because I have just, like, I don't even know what car it comes out of. I just had it delivered to me as in, this is an e-brake, we need to figure it out. So, yeah. That's what I've been trying to figure out. I got to the extent of powering it up, so as you can see, I've ripped the controller apart. I have found the CAN transceiver on it. It's that chip right there. I have put it on the oscilloscope, and I've done decoding on the CAN bus packets. I've made the motor run. So anyway, I'm partway through that process. But yeah, any extra information that can help would be very welcome. Okay, I am going to go. Now, all of you, I'm going to give you 2 missions for next week. One is to think about this whole thing of how should I structure this? And from the end point of view, what is the nicest way to represent tests to the end user? So the person who needs to define the tests, what is the simplest way to write the test sequence down so that it can be parsed by the test runner and then executed? And the other thing is, pay attention this week for nerd brags for next week. Wagon Low says, I reverse engineered a PCB by entering the traces into KiCad. Cool. Well, that can be your nerd brag for this week. Yeah, so thank you very much for coming along. I'm going to be pondering this, and hopefully you're going to be pondering this as well. And I am going to talk to you all next week. Thank you. See ya.